Hello everyone, welcome to New Wave Coaching Classes of Mathematics. This is your host Jatin. Today we are going to study a new topic, that is of circles. Right? Before we talk about the question answers and the theorems, let us discuss about the definition and some of the important definitions in the circle. Right? First of all, the definition of circle. Well, it is defined as collection of all those points it is defined as a collection of all those points which are at a fixed distance from a fixed point. Now here, this fixed point is basically the center of the circle, and the fixed distance is called the radius of the circle, right? So this is what we have. So collection of all those points which are at a fixed distance from a fixed point. So this is the fixed point. The center O is the fixed point, and this is the fixed distance. That is called as the radius. Now many of the things you have already discussed or learned in your grade 9. That is about the sector of a circle, chord of a circle. Then there were many other few things like segment of a circle, right? In this grade or in grade 10, you're learning something new. What are the new things you're going to learn? You're going to learn about tangent to a circle. Now this tangent is basically different from the tangent in the trigonometry you have learned. It is not the same tangent, it is a different tangent, right? Now what is a tangent basically? A tangent is a line, it is a line which touches the circle at one point. So if we draw a circle, so we have a line which is touching the circle at any one point, that is the tangent. You just draw like this, so this is the tangent. Right? So this is one of the tangent, this is the center O, I can just name it, this is P, this is Q. Now, a circle can have infinite number of tangents, we can draw infinite number of tangents, right? But from an exterior point, if we talk about an exterior point, a point which is just outside the circle, from this point we can only draw two tangents to the circle, or more than two. We can only draw two tangents, right? Well, circle can have infinite tangents. Right? And from a fixed point, we can draw two tangents to a circle. So if this is a point, say P, and this is A and this is B, so we say E and PB are the tangents from the point P of the point P is basically the external point on the circle, right? Let's go to the next thing now. Next we talk about a secant of a circle. Now this secant is again not the secant of the trigonometry we are talking about. We're talking about secant of a to a circle. Now what is a secant? Now you see the tangent is touching the point at touching the circle at one point. But a secant is a line which touches the circle at 2 points. At any 2 points. If a line intersects the circle at any 2 points, that line is called secant to a circle, right? So these are the two new things you have learned in this class. Now let's go to the first theorem of this chapter, right? Now the first theorem of this chapter is the tangent to any point of a circle is perpendicular to the radius through the point of contact. So let's see the first theorem and its proof. It's given the tangent to a circle is perpendicular to the radius at the point of contact. Now let's draw a circle first. So this is the circle. We draw a tangent here, right? This is the center O, right? So this is tangent A, B, and let's mark this as P. So OP is the radius of the circle. Now what is given to us? That AB is a tangent to the circle with center O, right? And obviously OP is the radius. Now what we have to prove here, we have to prove that OP is perpendicular to AB. Now before we start the proof, another point I want to discuss with you. If we have a point, external point, and there is a line, now how can we find the distance? There can be many lines which can be drawn from this point on this, from this point to this circle, or sorry, this line. There can be many line segments, right? If I talk about the shortest distance is basically the perpendicular distance, right? So what I mean to say here, the shortest distance between a point and a line is the perpendicular distance between them. Why I'm telling you? Because this property we are going to use to prove this thing, right? Now what we do, we take the proof of this theorem. We take a point suppose we take point here, say this is as Q. Take a point Q on AB. Then we join this O with Q, join O, Q. So we join it. Right, now this OQ is touching the circle at some point, and I name that point as R, right? Now what we have, I can write OQ equals to OR plus RQ. OQ is equal to OR plus RQ. Now this OR, instead of OR I can write OP. And why I can write it? Because P and OR are equal because OP equal to OR are radius or radii. Right? Now from here, what I can say that this means OQ is greater than OP. Now, we say if a number is a sum of two positive numbers, if a positive number is a sum of two positive numbers, then that number is greater than both of the numbers. Like if I say 5 is a positive number is a sum of 4 plus 1. So it means 5 is greater than 4 also and 5 is greater than 1 also. So using the same property, I can say since OQ is equal to OP plus RQ, so OQ will be greater than OP, right? Now, if I take this point Q anywhere on this line, if I take this Q point anywhere on this line except the P point, I say this is true, this is true for all the points on AB except P. Now, instead of taking Q here, if I take Q here, here, means that Q is not coming on P. Q is not coinciding with P. It means this will be true. If I take a Q point anywhere, it will be always greater than OP, right? So this means OP is the shortest distance between point O and line AB. And the shortest distance is always a perpendicular distance. So this means OP is perpendicular to AB. So this is the end of the proof. This is what we require, right? Now we go to the exercise 10.1, quite simple. Now the first question they have asked, how many tangents a circle can have? So a circle can have infinite tangents. Then we have some fill-ups to do. Now the second question, first part. Now the second question, first part says a tangent to a circle intersects it in dash points. So now how many points does a tangent intersect a circle? Or just only 1 point. So we write 1. Now the second part, they have asked a line intersecting a circle in 2 points is called. So we have already discussed a line which intersects the circle at 2 points is called a secant. Now the third fill-up, they say a circle can have dash parallel tangent at the most. So when we talk about parallel tangents, so at the most if I say this is 1, this is 2. So how many parallel tangents we have? So there's a pair. So we can say we have 2 parallel tangents, right? So a circle can have 2 parallel tangents at the most. So we write 2 here. Now let's go to the fourth part. Is they have asked the common point of tangent to a circle and the circle is called. So the common point is called as point of contact. So this is your second question, right? Now the third question. In the third question, what they've asked, they say a tangent PQ to point P of a circle radius 5 cm meets a line through the center O at a point Q. So that OQ is 12 centimeter and we have to find the length of PQ. Let's see it again. What they have given, there is the circle. So this is the center. Now there is a point, external point from which the tangent has been drawn. So this is the point P and we draw a tangent here, right? So this is P and this is Q, right? This point is P and this is Q and this is O, right? Now we just join it with the center and we make this. Now we have already done in the theorem that the angle between the radius and the tangent is 90 degrees. So the triangle which is formed here is basically a right angle triangle, right? So we can use the property of right angle triangle, that is Pythagoras theorem, to find any side if two sides are given to us, right? Now what they have given to us, they have given that the radius is 5 centimeter, OP is given as 5 centimeter and OQ is given as 12 centimeter. We have to find the length of PQ. So obviously OQ square is equal to OP square plus PQ square. So PQ square can be written something like this: OQ square minus OP square, that is 12 square minus 5 square, and on simplifying we get PQ square equal to 144 minus 25, that is 119. So this means PQ is equal to square root of 119 centimeter. So this is the solution of the third question of the exercise. Now we talk about the last question, that is the fourth question. It's a construction question. What we have to do, we have to draw a circle and then we have to draw two lines parallel to a given line such that one is tangent and the other is a secant to the circle. So it's quite simple. What you can do, you can just draw a circle, make a line and then draw a tangent parallel to that line and a secant parallel to that line on the circle. Right, friends? So this was all about the circle, about the tangent and the exercise 10.1. I hope you understood everything. Make sure to like and subscribe to my channel. Again, I say, if you have not understood anything, just write in the comment section. Right, so this is it from my side. This is your host signing off. Goodbye and take care.